You ever done this? You're standing on a beach, just watching the waves roll in, one after the other, and you start to wonder, just how many are there? It feels like this endless, constant rhythm, right? It's such a simple thought, but the answer, well, that's where things get really interesting.
So let's start with that question. On the surface, it seems totally straightforward. How many waves? Should be a simple number. But as you're about to see, that one little question cracks open this whole incredible world of ocean dynamics.
So what is it? What's the number? If you had to put a number on it right now, what would you guess? A few thousand? Tens of thousands?
Well, if you do some quick back-of-the-napkin math, and you assume a pretty typical wave comes in, say, every 10 seconds, you get 6 waves a minute, 360 an hour, and that adds up to exactly 8,640 waves in a day. Simple, right? Case closed.
Yeah, not so fast. That number, it's just a tidy, super simplified answer. The reality is so much more complex, way more variable, and honestly, a lot more amazing. To find the real answer, we've got to go all the way back to the very beginning. So where does a wave even come from? See, it's not just a lump of water moving, it's energy moving through the water. And that energy has to start somewhere. And almost every single time, it starts with the wind.
The size of a wave, its power, it all boils down to 3 key ingredients. First, how fast is the wind blowing? Pretty obvious. Second, how long does it blow for? Makes sense. And third, this really critical concept called fetch.
This third one, fetch, is the secret sauce. Imagine the wind is like a hand, pushing the surface of the water. The longer it can push across that water without being blocked by land, the more energy it pumps in. That's how you get these massive waves. A storm in the middle of the Pacific can use a huge fetch to create swells that eventually break on the coast of California, thousands of miles away.
All right, so once that energy is in the water, the wave starts this incredible journey, sometimes across entire oceans. But here's the thing. Not all the waves that show up at the beach are the same. Not even close. You've basically got 2 main types hitting the coast. First, you have the local wind waves. They're choppy, kind of disorganized, and created by winds that are pretty close by. And then you have the swells. These are the beautiful, organized, powerful waves that have traveled from those massive storms maybe halfway across the planet.
So how do they get so perfect and organized? It's this awesome process called wave dispersion. Think of it like a marathon. When the storm creates the waves, it's like all the runners starting at once. But over that vast ocean distance, the faster runners, the waves with longer wavelengths, they pull ahead, while the shorter, slower ones fall behind. So by the time they reach the shore, they've sorted themselves out into those clean, rhythmic sets that surfers are always looking for.
So, after its epic journey, our wave is finally approaching land. And this is where the grand finale happens. This is where it goes through its most dramatic transformation.
As the water gets shallower, the bottom of the wave starts to drag along the seafloor. It starts to feel the bottom. This friction slows it down, but all that energy has to go somewhere, right? So, it goes up. The wave gets taller, it gets compressed, and the distance between waves shrinks. This whole process is called shoaling, and it's what turns a gentle, rolling swell into a powerful crashing breaker. But wait, there's more. The final wave count is also getting messed with by a ton of local factors. What's the tide doing? What's the shape of the coastline? Is it a wide bay or a rocky headland? Are there underwater reefs or sandbars? All of these things can bend, focus, or block wave energy, completely changing how many waves actually hit the beach.
Okay, deep breath. We've seen how a wave is born, how it travels thousands of miles, and how it transforms at the very end of its life. With all of that complexity in mind, let's go back to our original question. What is the actual number? And the real answer is, it totally depends. On a calm day, on a coast that gets those long, organized swells, our original number of around 8,000 is actually pretty close. But on a more average coast with shorter periods between waves, you could easily see over 17,000. And on a really stormy coast, the waves could be pounding the shore every 3 seconds, pushing that count to almost 30,000 waves in a single day. And this gets to the most important point of all. We're not really counting things. A wave isn't an object, like a bowling ball. It's a pulse of energy that's just moving through the water. The water itself just kind of moves up and down. So counting waves is less like counting cars on a highway and more like measuring the pulses in a heartbeat. So why do we care? Why go through all this trouble? Well, it turns out that constant rhythm, that daily count of waves, is one of the most powerful forces shaping our entire planet.
Every single one of those thousands of daily waves is doing work. They are constantly carving out our coastlines, driving erosion, and acting like a giant circulatory system for the coast, delivering oxygen and nutrients that entire ecosystems depend on, from the tiniest barnacles to massive schools of fish.
I want you to think about it this way. Every wave is a messenger. It's a little packet of information, and it's carrying the story of a storm that happened days ago, maybe thousands of miles away. By studying these wave patterns, their frequency, their power, we can understand global weather, and we can even track the long-term effects of climate change, like rising sea levels and more intense storms. So the next time you're at the beach, you'll know. You're not just watching water, you're watching energy, you're watching information. You're watching a story arriving from the other side of the world. And the question is no longer just how many. Instead, it's what story is the ocean telling you with every single wave that comes ashore?